SER, or Service Entrance Rated cable presents specific considerations regarding its application, especially concerning underground use and wet locations, as dictated by a National Electrical Code, or NEC. When considering underground applications, Section 338.12b of the NEC permits the use of SER cable underground provided it is installed within a raceway. However, the selection of raceway is specific. The NEC Section 356.10c mandates that suitable raceways include rigid non-metallic conduit, often abbreviated as RNC, intermediate metal conduit, or IMC, rigid metal conduit, or RMC, or electrical metallic tubing, or IMT. It is crucial to adhere to these raceway types to ensure compliance and protection of the SER cable in underground environments. In the context of wet locations, it is important to recognize that SER cable is not inherently rated for such environments. This means that additional protective measures must be implemented to shield the cable from moisture. Installing the SER cable within a raceway, as previously discussed, is one method. Alternatively, the use of weatherproof boxes or outdoor rated luminaires can provide the necessary protection against moisture intrusion. The NEC emphasizes the importance of employing approved methods to safeguard electrical installations in wet environments, and SER cable is no exception. Comparing SER cable to SE, or service entrance, and use, or underground service entrance, cables highlights their distinct characteristics. SE cable shares similarities with SER cable in that it can be used underground when installed in raceways. Additionally, SE cable is rated for wet locations. Use cable, on the other hand, is designed for underground use without the need for raceways, signifying its suitability for direct burial applications. Use cable is also rated for wet locations. In summary, SER cable's application requires careful consideration of the NEC guidelines. While it can be used underground within specified raceways, it is not rated for wet locations and necessitates additional protection against moisture. Understanding the differences between SER, C, and use cables is essential for selecting the appropriate cable type for a given application and ensuring compliance with electrical codes. When considering the installation of SER cable, it is crucial to consult the latest edition of the National Electrical Code and local amendments to ensure adherence to all applicable regulations. Furthermore, it is recommended to consult with a qualified electrical inspector to verify the suitability of the installation and address any specific concerns or interpretations of the code. Always prioritize safety and compliance when working with electrical systems. The NEC provides comprehensive guidelines for electrical installations, covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment selection. Adhering to these guidelines ensures the safety of people and property. Firstly, understand the NEC definition of a raceway. Secondly, identify the appropriate type of raceway for the specific application. Thirdly, ensure that the raceway is installed correctly and securely. Fourthly, when routing SER cable in a raceway, avoid sharp bends or kinks that could damage the cable. Fifthly, properly seal the ends of the raceway to prevent moisture or debris from entering. Sixthly, consider using a pulling lubricant to ease the installation of SER cable in long raceway runs. Seventhly, regularly inspect the raceway and cable for any signs of damage or deterioration. Eighthly, repair or replace any damaged components promptly to maintain the integrity of the electrical system. Ninthly, consider the environmental factors such as temperature and exposure to chemicals when selecting raceway materials. And tenthly, always disconnect power before working on any electrical system. Regarding wet locations, the NEC defines them as areas subject to saturation with water or other liquids. These locations require special precautions to prevent electrical hazards. When installing SER cable in wet locations, firstly, use only approved wiring methods and equipment that are specifically designed for wet environments. Secondly, ensure that all connections and terminations are properly sealed to prevent moisture ingress. Thirdly, consider using ground fault circuit interrupters, or GFCIs, to provide additional protection against electrical shock. Fourthly, install equipment above the flood level to minimize the risk of submersion. Fifthly, use corrosion-resistant materials for enclosures and supports. Sixthly, regularly inspect the wiring and equipment for signs of corrosion or damage. Seventhly, implement a preventative maintenance program to address any potential issues before they become hazards. Eighthly, consider using a waterproof sealant to protect exposed connections. Ninthly, provide adequate drainage to prevent water from accumulating around electrical equipment. And tenthly, always follow the manufacturer's instructions for installation and maintenance. Regarding the comparison of SER, C, and use cables, it is essential to understand their distinct characteristics and applications. SER cable, or service entrance rated cable, is primarily used for service entrance wiring and feeder circuits. It typically consists of multiple conductors with a flame-retardant, moisture-resistant insulation. SE cable, or service entrance cable, is similar to SER cable but may have different construction and insulation requirements. Use cable, or underground service entrance cable, is specifically designed for direct burial applications and has a moisture-resistant insulation suitable for underground environments. When selecting the appropriate cable type, firstly, consider the specific application and environmental conditions. Secondly, consult the NEC and local codes to ensure compliance with all applicable regulations. Thirdly, evaluate the voltage and current requirements of the circuit. Fourthly, assess the potential for exposure to moisture, chemicals, or other corrosive substances. Fifthly, determine whether direct burial is required or if a raceway is necessary. Sixthly, select a cable with the appropriate ampacity and insulation rating. Seventhly, ensure that the cable is properly supported and protected from physical damage. Eighthly, follow the manufacturer's instructions for installation and termination. Ninthly, conduct a thorough inspection of the installation to verify its integrity. And tenthly, maintain accurate records of the cable type, size, and location for future reference. In addition to the previous points, it is important to emphasize the significance of proper grounding and bonding in electrical systems. Grounding provides a low impedance path for fault current to return to the source, helping to trip over current protection devices and prevent electrical shock hazards. Bonding ensures that all metallic parts of the electrical system are electrically connected, minimizing voltage differences and reducing the risk of shock. When implementing grounding and bonding, firstly, use a grounding electrode system that meets the requirements of the NEC. Secondly, connect all metallic enclosures, raceways, and equipment to the grounding electrode system. Thirdly, use bonding jumpers to connect separate sections of metallic raceways. Fourthly, ensure that all ground connections are tight and corrosion resistant. Fifthly, protect ground wires from physical damage. Sixthly, regularly inspect the grounding system for any signs of damage or deterioration. Seventhly, test the grounding impedance to verify its effectiveness. Eighthly, use appropriate grounding techniques for sensitive electronic equipment. Ninthly, consider the use of isolated grounding systems in areas with high levels of electrical noise. And tenthly, always consult with a qualified electrician to design and install the grounding system. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of fire. When selecting and installing overcurrent protection devices, firstly, choose devices with the appropriate ampacity rating for the circuit. Secondly, ensure that the interrupting rating of the device is sufficient for the available fault current. Thirdly, install overcurrent protection devices in readily accessible locations. Fourthly, protect overcurrent protection devices from physical damage and environmental factors. Fifthly, use the correct type of overcurrent protection device for the application, such as inverse timed circuit breakers or current limiting fuses. Sixthly, coordinate overcurrent protection devices to ensure selective tripping. Seventhly, label overcurrent protection devices clearly to indicate the circuits they protect. Eighthly, regularly test overcurrent protection devices to verify their functionality. Ninthly, replace overcurrent protection devices that have tripped repeatedly or show signs of damage. And tenthly, always follow the manufacturer's instructions for installation and maintenance. Furthermore, it is essential to understand the requirements for conductor ampacity. Conductor ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that specify the ampacity of various conductor types based on their size, insulation, and installation conditions. When determining conductor ampacity, firstly, select a conductor size that is adequate for the load it will carry. Secondly, consider the ambient temperature and dare the conductor ampacity accordingly. Thirdly, account for the number of current carrying conductors in a raceway or cable. Fourthly, use the correct correction factors for conductor bundling. Fifthly, ensure that the conductor insulation is suitable for the operating temperature. Sixthly, protect conductors from physical damage and environmental factors. Seventhly, terminate conductors properly to ensure a secure and reliable connection. Eighthly, regularly inspect conductors for signs of overheating or damage. Ninthly, replace conductors that are undersized or have damaged insulation. And tenthly, always consult the NEC and manufacturer's instructions for specific ampacity requirements. In addition to the technical aspects, it is crucial to emphasize the importance of electrical safety training. Electrical work can be hazardous, and it is essential to have the knowledge and skills to perform tasks safely. Electrical safety training should cover topics such as hazard awareness, lockout-tagout procedures, personal protective equipment, safe work practices, and emergency response procedures. Electrical safety is not just a set of rules, but a mindset. It requires constant vigilance and a commitment to following safe work practices. Never take shortcuts or compromise safety for the sake of convenience. Always prioritize safety and take the time to do the job right. Firstly, identify potential electrical hazards in the workplace. Secondly, assess the risks associated with those hazards. Thirdly, implement control measures to eliminate or reduce the risks. Fourthly, provide employees with adequate training and resources. Fifthly, enforce safe work practices and procedures. Sixthly, regularly inspect electrical equipment and systems. Seventhly, investigate any electrical incidents or near misses. Eighthly, review and update the safety program as needed. Ninthly, promote a culture of safety throughout the organization. And tenthly, lead by example and demonstrate a commitment to electrical safety. The information provided serves as a general guideline. Always consult the latest edition of the NEC local codes and qualified professionals for specific applications and requirements.